Hello everyone, welcome to the channel MathSKfunde. Hope you have been enjoying mind-tickling problem series. Today's problem is fifth problem. That means previous four problems I guess you must have solved. You must have enjoyed them too. Now, before I start today's problem, I'm repeating once more. I have another channel named Aaj Aapko Kya Sikhaye, where explanation is given in Hindi, and link of that channel I give at the end of every video of this channel. There too, I have started with a series called Mind Stretching Problems. Problems discussed over there, they are different from what I discuss here. So please visit that channel. There is no dearth of problems. Keep solving. Now, I start with today's problem, where I'm given three expressions named Px, Qx, Rx. Qx and Rx, they involve log terms with base 2 and 4 and quantity like 2 raised to x and 2 raised to minus x. These are also involved. One relation is given, Px equal to 2 times Qx minus 2 times Rx, and we have to find the sum of values of x that satisfy this relation. Now, before jumping to Px equal to 2Qx minus 2Rx, I prefer to see carefully how Qx and Rx are behaving. See, their base is different. At one place it is 2, at another place it is 4. So whenever you want to tackle two log quantities, it is better to make same base. So if I start with Rx, where base is given to be 4, I need to change here base. So I use change of base property and I rewrite it as log of 2025 minus 2 raised to minus x upon log 4. Base is everywhere 2. Now log 4 can be written as 2 log 2 and base is still 2. Now log 2 to the base 2, this I can replace by 1. You know this property. And further I simplify this to log of 2025 minus 2 raised to minus x upon 2. This is a simplified version of Rx. Now I may start with Px equal to 2Qx minus 2Rx, which is given to me, right? So if I start with that, I will have to substitute for Qx, that is given to be log of 2 raised to x plus 3 to the base 2, and 2Rx you can just find from here. This 2 you can multiply here, and then 2Rx expression would become log 2025 minus 2 raised to minus x base 2. Now substitute that whatever I just mentioned and try to simplify this further. Now this first part is of the form n log m, and n log m you can write as log of m raised to n, and then finally the entire quantity on the right hand side can be thought as of the form log m minus log n. So that is written as log of m upon n. So basically what I am saying is nothing but properties of log. Using that, you write expression for Px, and that comes out as log base 2, and inside quantity is 2 raised to x plus 3 whole square upon 2025 minus 2 raised to minus x. So what I have here is Px log base 2, and inside quantity is in terms of 2 raised to x and 2 raised to minus x both. So it's better to write things in terms of 1, either 2 raised to x or 2 raised to minus x. That is in my mind. And also we have not yet replaced for Px. So I write for Px also, that is x plus 1, and then that 2 raised to minus x I have written as 1 upon 2 raised to x and then simplified. So after simplification, what I'm getting is log 2 raised to x plus 3 whole square into 2 raised to x upon 2025 into 2 raised to x minus 1. Now use simple definition of log. So this 2 raised to x plus 1 you will get. So 2 raised to x plus 1 equal to this quantity written inside bracket. So that is nothing but 2 raised to x plus 3 whole square into 2 raised to x upon 2025 into 2 raised to x minus 1. Now at least at all the places I'm getting now 2 raised to x. So it's better I name that 2 raised to x as t. So writing will become easy, nothing else. Now if I write the 2 raised to x as t and write equation in terms of t, I am getting 2t into 2025t minus 1 equal to t plus 3 whole square into t. Now obviously all of you must be jumping to cancel this t with this right hand side t. But before doing this, please understand you have to make sure that t is not 0. Yes, t is greater than 0. Why t is greater than 0? Because t is 2 raised to x, and 2 raised to x means this is an exponential quantity, and every exponential quantity is a positive quantity. That would never be 0. So I can cancel t, and I will finally get one quadratic equation, that is t square minus 4044t plus 11 equal to 0. Now, this is one quadratic equation which we need to look at to evaluate the sum of the values of x at the end. Okay. So, if t1 and t2 are the roots of this quadratic equation, I know what is sum of the roots. I know what is product of the roots. Use formula of quadratic equation. So, t1, t2 product would be 11. And now I take log on both sides, and base I still keep as 2 because from beginning we have been taking base as 2 only. So I get log t1 plus log t2 equal to log 11. Base is 2 everywhere. And what about log t1 to the base 2? Is it not x1? Because 2 raised to x was t, right? So log t1 to the base 2 is x1. Log t2 to the base 2 is x2. So what I'm getting here is x1 plus x2 equal to log 11 to the base 2. And what we were interested in finding, find the sum of the values of x. Means basically what we are interested in is x1 plus x2. So that is log 11 to the base 2. And that is my answer. Now, hope you have enjoyed this because there were so many quantities like exponential quantities, log, etc. Properties of log also we revised. I'm sure you enjoyed. I will get something new again on next turn. Till then, stay tuned. Thank you.